Let's talk about pivot columns. So the pivot columns of R have ones in the pivots and zeros everywhere else. Now if you take an example here, uh, let's take an example of matrix A. So matrix A is equal to 1, 3, 0, 2, minus 1, then 0, 0, 1, 4, minus 3, 1, 3, 1, 6, minus 4. So if we go for elimination process and we find this reduced row, now only term is that, okay, let us do this. So what do we get here? So just subtract the row 3 minus row 1. So we will get here, that is 1, 3, 0, 2, minus 1. So this remains to be same. So this is 1, 4, minus 3. And the last row will become 0 here, that is 0, 0. So now here we have 1, and here we will get this as 4, and here I will get here this as minus 3. So we got this. So now what we will do is that the new row 2, sorry, this row 3 minus row 2 we will do. So then finally we will get this as 1, 3, 0, 2, minus 1, and we have here 0, 0, 1, 4, minus 3, and then the last row will become 0, 0, 0, 0 entire. And now we have the two pivots here, that is this and this pivot. And the rank of the matrix here, the R is equal to 2. And it says from this pivot that the R pivot columns taken together contains an R by R identity matrix perfectly. If you look into this, the two columns, it is the identity matrix here exists, and it sits exactly above M minus R rows of zeros. So what is the M here? So this is basically M cross N matrix. So M cross N, it means that it has 3 rows and how many columns? 1, 2, 3, 4, 5 columns. So the value of N is equal to 5. So here the rank of the matrix is 2. So then the reduced row matrix will sit above the M minus R rows of 0. Sit above the M minus R above the 0. So it means M minus 5. So here it is 3 minus 2 is equal to 1. So it means it will sit this above one row. So now this is sitting exactly above one row of the 0. So that is what it means. And the pivot columns, in short, we call here as PIVCOL, pivot columns. So and also if we look into the elimination matrix here, so the elimination matrix, that is E into A is equal to R. So if we try to represent this reduction method, the row reduction method in terms of elimination matrix, then what should be the elimination? So first we have eliminated so this point here, so then we have eliminated this point here if we take this identity matrix. So now the elimination matrix for this case is nothing but the modified version of the identity matrix. So we have 1, 0, 0. So now we have taken out this last position, so this remains to be 0, this is 1, and this is 0, no change. Whereas here this will become minus 1, and as well as we have taken this one also in this case. So even that will become the minus 1, and the last what is the 1 as per the identity matrix. So we have taken this as well as this position. So you see this, we have taken this 1 as well as this 3. So therefore we have to put there as minus 1. because those are the multiplying factors here in the elimination matrix. Now if you multiply this elimination matrix with A, what do I get is that I'll get my reduced matrix R, or I can write this in the other way, that A is equal to the inverse of elimination matrix multiplied by R. So what is the inverse of this elimination matrix? So we know that we have seen in the previous tutorial that you just change the sign of this elimination matrix. Rather than subtracting, you just add those uh, multipliers. So here we have 0 0 0, then 0 1 0, then this is 1 1 and 1. So this is my inverse of elimination matrix. So if A can also be obtained from by multiplying inverse of the elimination matrix with the reduced matrix here. So then we can state that the pivot columns are not combinations of earlier columns here. If you see in the reduced form, so this is the reduced form here. So the pivot columns are not the combinations of any earlier columns, so it is independent, and the free columns are the combinations of the earlier columns. So if you see here 3, if I multiply the column 1 by 3, I'll get the column 2, and if I multiply 2 to column 1 and my column 3, these are my pivot columns, I'll get my this what do you say, the column 4. And if I multiply minus 1 and minus 3 to column 1 and 3, I'll get my column 4, sorry, column 5. So that is what this definition says. So let me write the definition here. So pivot columns are not the combination of earlier columns, whereas the free columns are the combinations of earlier columns. So the pivot columns are not combinations of earlier columns, but the free columns are combinations of earlier columns. So these combinations are the special solutions. That's it. So let me write that one also. So these combinations are the special solutions. So let's talk about something on these special solutions. So let me save this page here. So let's talk about the special solutions. Okay. So each special solution for Ax. So far whatever we are discussing, it is with respect to, that is Ax equal to 0. It means still we are discussing with respect to the null space. The right hand side is no value. We are considering the right hand side of the values of the vector is equal to 0. So we'll see next when Ax is equal to b. When it is not equal to 0, then how to find the solutions, that we'll see in the next as we progress. So let us talk about this special solution. So when for each special solution, that is Ax equal to 0 and Rx is equal to 0, has one free variable which is equal to 1. That is true, we all know that. So to find these special solutions, we make any one of the free variables as 1 and all other free variables as equal to 0. So that is how we are going to find these special solutions. So I will not going to take any example here because we already know. So here I want to highlight few points here, and then we'll quickly progress through, because we have seen quite a number of examples here. So let's not waste our time. So there is a special solution for every free solution. Yes, this is also right. So for every free variable, there is a solution, or there is a solution for every free variable. Like that also we can quote this. So since our columns have pivots, that leaves n minus r free variables. So that is another way of looking into that. So for example, okay, let's take a quick example here. I'll not go in much detail. I'll just take r into x, the reduced form already, which is in the reduced form. That is a continuation of the previous example itself. That is 1, 3, 0, 2, minus 1. So this is 0, 0, 1, 4, minus 3, and this last row is 0. So then we have, that is x1, x2, x3, x4, and we have x5 column, and the right hand side is equal to 0. Okay, then the special solutions and all we have already seen before, so I'll not go in much detail. So here only point which we need to highlight is that, okay, so let me write the special solution here. So special solution, so here how many free variables we have? So we have here this is free variable, so this is my free column, so this is also my free column. So it means we have 3 free variables, so 3 free columns and 2 pivot columns. So it means I'll get the 3 special solutions. So what are the 3 special solutions? If you just look into this directly, if I make this as this column with its variable 1 and remaining columns are 0, so to get this, what I need to do, I have to consider this x1 is equal to minus 3, then this is equal to 1, and all others should be equal to 0. So I'll get here 0. So this is my first solution. So second solution, what do I get here? So second solution, if I make this fourth column variable is equal to 1 and all other free variables is equal to 0. So to get this, I have to combine the 2 pivot columns here. So I need to multiply this by minus 2. Sorry, let me write neatly. So this is minus 2. So this is 0 anyway. So then I'll have this is also minus 4. This I have to multiply with minus 4. So then the last one, I'll get this as 0, and then this is 0. Sorry, this we have made 1, right? So this is 1 and this is 0. And the last solution I'll get here is that, so S3 is equal to, so if I make the fifth variable as equal to 1, then for that this x1 will become 1 and this is 0 and this is minus 3 I'll get. So and the remaining, this is 0 and this is 1. So these are my 3 special solutions. So if you write this in the null matrix, in the null space matrix, then the null space matrix, then we can write this as n minus r is nothing but which is equal to 5 minus 2. It means we have 3 special solutions. This is another way of looking into it. So how many special solutions? See, one method is that as the number of free variables are 3, we can say that there are 3 special solutions. The other way of looking into is that we can also write this as n minus r. So n is nothing but the number of columns in the A matrix minus the rank of the matrix. So we have 5 columns, so 5 columns minus the rank of the matrix. That will also give us how many special solutions we will get. So this we can write this as, so n is equal to, we can write this as now write all these special solutions, that is 0, 0, 0, and this is minus 2, 0, minus 4, 1, 0, and this is 1, 0, 3, 0, 1. So if you just want to highlight that, just so let us highlight a few points here. So Ax equal to 0 has r pivots and n minus r free variables. So that means there are n columns, n column minus the same thing, n column minus r pivot columns. So then the null matrix space n contains n minus r special solutions. So then we can straight away write this is equal to a into n is equal to 0. So that is about it. Now let us write this in the generalized form. So if ax equal to 0 has r independent equations, so it has n minus r independent solutions. So n minus r independent solutions we have. So that can be written as in a very general form. So let us write. Let me save this page here. Page 96. So then we can write this the reduced matrix as identity matrix, because we have identity matrix and also we have the free columns, and below few of the rows will be 0. So it means the rank of the matrix, so R has R pivots. Let me write like this. So it means it is R pivot rows, then it has M minus R 0 rows. So it will be having M minus R 0 rows, and then if we write here, so it means it is having R pivot columns in terms of columns if we talk, and then it will be having n minus r free columns. In terms of rows if we talk, it has r pivot rows and m minus r 0 rows, and it will be having r pivot columns and n minus r free columns. So if you write this in terms of the null space matrix, the null space matrix n is equal to, so we'll get this as minus f and identity matrix that we can see from the previous example. So in the previous example we had this n is equal to, what do we had? I'll just write one of the columns, so minus 3 1 0 0 0. So how did we get this minus 3? So minus 3 is nothing but the value of one of the free um, uh, column, and the I is depends on the identity matrix. Now if you write this generalized form, so then n is nothing but the minus f into I. It has identity matrix below and above the free column values. That is what it means. Okay, so this is about the uh, solution to this column, the special solution.